Hi, my name is Sandro Cirulli and I work for Oxford University Press. In this screencast I'm going to show how we use continuous integration at Oxford University Press, and in particular how we use tools like Jenkins, Docker and Docker Compose in one of our projects. First of all, I apologize for the poor quality of the audio. I'll try to see if I can record the screencast with a better audio in the next days. I'm going to discuss the workflow that we use for continuous integration. Then I'm gonna walk through some of the scripts that are involved in the workflow, and finally I'm gonna do a quick demo using Jenkins. This is the continuous integration workflow that we use. It's very simple and straightforward. It starts with a developer that commits changes to the code base. This triggers unit tests, a Jenkins build that runs unit tests. If the tests pass, then the Docker image is rebuilt and the Docker container is restarted using Docker Compose. Should the unit tests be unsuccessful, then the latest developer who committed the code is publicly shamed on the monitor view, which is in a prominent place in our office on a screen which is visible to everybody. So now I'm going to walk through some of the scripts and tools that we use in the continuous integration workflow. I'll start with Jenkins, and first thing I want to show you the API unit tests job. I'm gonna open the configuration and I want to highlight two parts in here. First part is the build triggers. Jenkins is pulling the SVN server every 15 minutes to check that there are if there are changes in the code base, and if so, it will trigger this Jenkins job API unit tests. I must point out this is quite inefficient. It would be much better for the SVN server to have a webhook, so that as soon as there is a change in the code base, as the SVN server sends a notification to Jenkins, and Jenkins triggers this build. Because we are in the process of moving our code base from SVN to Git, then we have not implemented this in SVN, but we are definitely going to implement it in Git. The other part I want to highlight is the shell script that is run. We're using the Nose unit test framework for Python for running unit tests, and this includes also the code coverage with reports, starts, and all that. The second job in Jenkins that I want to show you is this API Docker build. Again, I'm going to open the configuration and I want to highlight two things in here as well. The first one in the build triggers is this box built after other projects are built, and we can see the dependency with the API unit tests. So when this job is built, is stable, then it will trigger the build of the API Docker image, and this is done by invoking this shell script update.ch that we will see immediately. This is the update.ch shell script, and I want to highlight a couple of things in here. First of all, these environment variables, they are identifying the server in which this script resides. Please note that these IP addresses are obviously fake. As you can see, I modified them all for obvious security reasons. And you will see then that this server environment variable is used at the very bottom of the script in here, and then it is passed. This is a way for us to maintain one single script that is used for 4 different environments: dev, stage, live, and even a standby, hot standby environment. We will see this use of environment variables in all the different scripts, as this is the solution that we implemented for maintaining one single script that works for 4 different configurations. Here you will see the Docker build commands for building the image, and we're also tagging the image with the SVN revision number that is passed from the Docker build job in Jenkins, and we tag it also as the latest version. This last part invokes the script manage lib components.ch. This is a shell script that my colleague Mary Chell has written, and it is a wrapper around Docker Compose commands. The idea was that anybody in the team can run this shell script, which interacts with the developer, asking questions, you know, where in which environment do you want to build the new component, where do you want to start it, and so on. So it's a way for anybody in the team to start and stop components without knowing the Docker and Docker Compose commands. And we're going to look at this script later, but first I want to show you the YAML file for the Docker Compose. You will see these are all the services that we are using in our project. There are quite a few. The one I want to highlight is the API service, and I want to highlight 2 things. I want to highlight the links to show that this container is actually linked to other containers, typically GraphDB, which is our triple store, RDF triple store, and as well as other components for caching and for logging. And then these environment variables, again, they look a little bit odd, especially the last 3, because there is no value, but we will see later that this is again a way to have one single YAML file for 4 different environments. Basically, the Docker Compose file is built at runtime by substituting, by replacing the this empty value with the URL for a specific server. You will see there are several environment variables with URL, and again this is set up in the configuration of the shell script. At the very beginning, environment variables are set, and then the Docker Compose file is the environment variables specific values are added in here via a simple substitution using the sed command. We will see this in the next script, which is the manage lib components. First of all, I want to show you this instructions that are basically replacing, according to the value of the environment variable, the Docker Compose file. And this is how these environment variables are then populated with the value related to the specific host name. Again, this is a way for us for having one single script which works for 4 different configurations, and even more if we want to. And then in this script, which is a wrapper around the Docker Compose commands, I want to highlight a couple of things. So you will see there are Docker Compose commands here. This one is for building, this one is for stopping a component, and then also doing some house cleaning. We allow a graceful shutdown, so we allow 30 seconds before sending the kill signal.